Now we have rational exponents. So these are exponents that are no longer whole numbers like 5 or 7 or 2, but instead are things like 2/3 or 4/3 or 3/8. So these are exponents that are going to be fractions. And before we get into that, though, we're going to just need to remember a couple things. For instance, the square root of 4. We need to remember that that is simply 2, or that the square root of 9 is just 3. However, how do you get that? Well, you could, if you wanted to, break 4 up into its prime numbers. So break it down to what multiplies to 4? Well, 2 times 2. 2, what multiplies to 2? Well, 2 times 1. And I don't want to go that low. I don't want to go to 1s. I want to leave it at the smallest prime number, and 2 is the smallest prime number. And then you're looking, this is a square root, which is 2 sides, the square root. So you're getting into pairs. So I have a pair of 2's, which is why I wrote 2. 9, for instance, that is 3 times 3. I can't break down 3 anymore. I got a pair of 3's, which is why my answer is 3. If I had something like the square root of 16, well, I could go 8 times 2, 4 times 2, carry this one down, 2 times 2, carry this one down, and also carry this one down. And I get them into pairs, pair of 2's and a pair of 2's. So this pair times that pair, 2 times 2 is 4. And you should know that the square root of 16 is just 4. And in the same way, if you don't know off the top of your head, well, what is the cube root of 16? Sorry, not the cube root of 16, but the cube root of 8. Maybe that's not entirely obvious. What is the cube root of 8? Well, you can break that down to 4 and 2. That 4 can be broken down to 2 and 2. You can carry this down. And because of the cube root, you're looking at groups of 3. Well, I've got a group of 3 there. So cube root of 8 is simply just a group of 2 or just 2. Or if you had the cube root of, I don't know, 27. And so you could break that down. That's going to be 9 times 3. 3 times 3, carry that down. There's a group of 3's because I'm getting them into triples. So I got a group of 3's, and that's everything. So the answer is just 3. So it's good to just know that as we get into something like this. Now, we can write, this is in power form, 8 to the power of 2/3, but you can write that as 8, and the numerator, the 2, is the squared, and the denominator is the radical. So you can write it like that. And you can actually see that here in the definition. X to the power of m over n is the numerator is with the x, and then the denominator gets thrown out as the radical. But you don't have to do this in this order. You could do this in a different order. So you can see here with the x, the x, the m is happening to it first, and then it's being rooted. But here, in this version, the x is being rooted first, and then the m is the exponent happens last. So you can have the m go first, or you can have the m go last. It doesn't actually matter. In this case, our m is our 2. So we can have the 2 go first, or we can have the 2 go last. And if we go last, then that means we're going to have the cube root go first. So it's this or this. Now, when it comes to evaluating it without a calculator, like, well, what is this? You can do it 2 ways. We can do it option number 1. You could do the cube root of 8 squared, which is the cube root of 64. And that might not be entirely obvious to you because the number is maybe a little bit larger. Or you could do it the second way, which is the cube root of 8 all squared. Now the cube root of 8, which number times itself gets you 8. Well, the only number that's true is 2. So cube root of 8 is 2, and then we can square it. 2 squared is 4. And I find that if you do the root first and then do your exponent, your squared or your cubed or whatever last, that the numbers are generally a little easier to work with. If you square it first, in this case, you're going to get a higher number like 64. Notice here, the highest number we got was the 8. We cube rooted the 8 to get a 2, and then we squared it to get a 4. So I'm going to do that first. I'm always going to do the radical first, or the denominator first. So here I've got 64, and then I have the denominator, which is a cube root, and then I'm going to have the numerator, which is squared. Notice, by the way, if we did it the other way around, if we did the squared first, then in order to evaluate this, I'd have to know what 64 squared is. And I honestly have no idea what that is. I'd have to do some sort of long multiplication. So I'm going to erase that. I have to do the cube root of 64, and then I have to square it. Now, I don't actually know what the cube root of 64 is, so maybe off to the side. Well, first I'll write it. The cube root of 64 squared. So I'll write off to the side here. The cube root of 64. Well, that is 2 and 32. 32 is 8 times 4. Carry that down. 8 is 4 times 2. 4 is 2 times 2. This 4 is 2 times 2, and then carry all of these down. There's a lot of 2's here. Because it's a cube root, I'm getting them into groups of 3. So I've got a group of 2's and a group of 2's again. So 2 times 2 is 4. So the cube root of 64 is just 4. And then I could square that to get 16. Moving on, 27. I can do the denominator, so the cube root of 27, and then to the power of 4. Or I could do it the other way, but I want to stick with this. So I can do the cube root of negative 27, and then I'm going to go to the power of 4. The cube root of 27, you can do that up to the side, but it is just 3. But there is a negative there. Now you can't take a square root of a negative number. A cube root being odd, you actually can. So the cube root of 27 is 3, and the negative is still there. So if I went negative 3 times negative 3 times negative 3, negative 3 times negative 3 times negative 3, there would be 3 different negatives, an odd number, which is still negative, and 3 times 3 times 3 is 27. So the cube root of negative 27 is indeed negative 3. Negative 3 times negative 3 times negative 3 is negative 27. And you're just going to have to know that. Now I have to go negative 3 to the power of 4. Well, I've got 4 negatives, which is a positive. And then 3 to the power of 4 is 3 times 3 times 3 times 3. Well, that's 9, and that's 9. 9 times 9 is 81. So again, the idea is that we're trying to switch this into radical form, and then we're evaluating it.